Today, I'll be showing you guys how I completely redesigned this line follower robot. Not only to make it faster, but also more accurate and completely custom with my very own ESP32 S3 breakout board. But first, let's rewind back to about 2 months ago when I first showed you this robot. You see, the competition I'll be going to in July, RoboRave International, requires the line following robots to deliver ping pong balls into this tower with a hole at the top. Considering the tower is 20 centimeters tall, you can probably see already what the old robot was lacking. On top of this, I needed an ultrasonic sensor to detect the tower, and more reflectance sensors to detect intersections and sharp turns, if I was even going to have a chance of completing the course more than 25% of the time. So in this video, I'll be taking you through all the failures and occasional successes that I had with trying to whip some speed, accuracy, and ping pong ball delivering capabilities into this robot. So first off, how do we get it to go faster? Well, it's quite simple actually. If you think about the fundamental concept of the robot missing or skipping over the line, that means that all of the sensors have passed over it, but either the microcontroller or the sensors have said screw you and decided that the motors aren't going to spin the way you want them to. Since you can tell the microcontroller to sample at a quicker rate through code, but you can't really fix the hardware limitations of the line sensors as easily, it's probably a better idea to fix them first and then just deal with the code later. So instead of this 5 sensor array, I quickly designed an 8 sensor one in KiCad, which is curved because it looks cool. Those extra sensors, in theory, should give us more chances to sense and react to the line on sharp turns, meaning we should be able to go faster. That's the same reason why you see some line followers looking like this. But obviously for this competition, we don't need to go crazy fast because there's still an extra load that needs to be carried, which might topple over if we go too quickly. To accommodate the 8 sensor array as well as the buck converter and the custom ESP32 S3 board I made 2 videos ago, I also had to create a carry PCB, but I'll spare you the details of that since it's already on my GitHub. Basically, all you need to know is that the microcontroller is now 15 times faster, and the motors are supplied by a constant 9 volts instead of directly from a 2S or 3S LiPo. Okay, the PCBs are all done now, so let's take a look at how we can order them with this channel's sponsor, PCBWay. First, you can sign up using my link in the description to get $5 off your first order, and once you're done, you can head over to the quick order page and upload your file, select the right parameters, and add it to the cart. Or better yet, if you're using KiCad like me, you can just click on the PCBWay plugin, and all the necessary files and parameters will be uploaded to the quick order page in just one click. About a week later, here are the PCBs, and they look great even with these 0.2mm tracks here on the carrier PCB. I ordered the line sensor assembled as well, with these reflectance sensor chips, and all 5 came in separate ESD safe bags, which is nice for no additional charge. You can get 2-layer boards like these for just $5 when you buy 10, so make sure to check out PCBWay after the video. So yeah, it doesn't really look that different, but I reprinted the chassis in green PLA, fixed the placement of this battery connector, and filled up some of the weird empty space on the front of the board with this buck converter, and my much wider custom ESP32 S3 board. I also 3D printed and 3D penned this attachment at the top connected through these poles, which can deliver ping pong balls into the tower I mentioned before, to give us more points. Anyways, I'm just going to modify the old code now for the new line sensor array, and get all the pin numbers so we can see how well it runs. After a couple runs where the robot just randomly stopped though, which couldn't even be prevented by resetting the ESP32, I knew something was seriously wrong, so I got out my multimeter. And sure enough, the buck converter's output was shutting down even under the light load of probably less than 500 milliamps that both motors were drawing, an eighth of what it was rated for. So it was time for plan B, and after realizing none of my local electronics stores carried something even remotely similar to the buck converter I was using, I searched up if any of them had an IC that could do it, and I found the LM1084, a 5 amp LDO, which only needed an extra 4 components to function well. Most notably, these two resistors set the output voltage of your system, and I chose values of 110 and 680 ohms to give the motors a constant 9-volt supply, like I had before.
6 hours later.
So it's around 9:55 right now, and we're going to be heading over to Ultrasonic just for a tiny little voltage regulator because obviously the buck converter didn't work. And as you can see from the local radar, it was pouring buckets and we had about a 30-minute trip ahead of us. So after a $13 toll and a bunch of tunnels and highways, we finally arrived at Ultrasonic in Virginia. As soon as I arrived there, I was greeted by one of the store's reps, and he proceeded to help me find all the parts I needed, starting with a small heatsink kit. We also got the nuts and bolts to attach it to the voltage regulator, and then he led me over to the large selection of resistors and capacitors, where I chose 2 resistors with a different wattage. Since I had all the parts I needed now, I wanted to clarify something about the voltage regulators as well. I saw their HD semi. Do you think that'll still do the same as like the Texas Instruments one?
If the part number is the same.
Yeah, the part number's the same.
The specs should in theory be the same.
Alright.
I've not gone through all the spec sheets.
It's alright, but on your website it says 5 amps, and that 5 amps is all I need. It's same thing listed in the Texas Instruments. So yeah, should be alright. Thanks. So after some of the worst soldering I've ever done in my life, here's the voltage regulator, which is a little less efficient compared to the buck converter, but at least it works and the robot can finally get through the whole course now. So all we need to do now is put back on the tower attachment and see if we can get the full thing running. But of course, it wouldn't just be that simple, would it? You see, adding the tower back on increased the robot's weight pretty significantly, meaning that the center of gravity was no longer around here and more like around here. And basically what that did is...
But what the hell?
Yeah, that's not good. But no stress, I'll just spend 3 hours coding a program to accelerate and decelerate the robot more smoothly, and then realize that that isn't even possible because the motors will only turn on and have enough torque to move the robot above a certain voltage. Well, that's fine. Why don't I just tape some coins to the bottom of the robot? And wow, look at that! It works! Wait, it doesn't. Let me just fix that real quick. My ultrasonic sensor housing sticks out in front of the sensor too much, which was causing it to see things that actually weren't there. So let's go for a full run now. Yay, it works. Turns out, my dumb ass didn't realize that A, the robot is front top heavy, and B, if you don't bring the robot to a complete stop, almost none of this rocking stuff will happen. So it takes the robot about 19 seconds to complete the course so far, but obviously I'll have to improve that for the competition, and also I'm not using the 2nd or 7th sensors yet, so that should help. Wait guys, before you go, I just want to say thanks for all the support in the previous videos, especially this one. So, when I hit 1,000 likes on this video, 3 of you who like, subscribe, and comment will get one of these line sensors. And When I hit 3,000 subscribers, I'll be giving away one of these 8 sensor ones too. Also, make sure to hit that notification bell so that you don't miss my next video, where I'll be creating a very exciting ant-weight combat robot.